captures your imagination, because if it doesn't capture your imagination, you're not going to be able to make it interesting to someone else. So I'm trying to fit into a portfolio of presentations here. And so Mike asked me to talk a little bit about research. Now that's a little presumptuous, I think, on my part. We've got a panel here who are all equally or better able to speak to those issues than I am. So but I'm going to talk a little bit about research, and in doing so, not say do this, do that, or do the other thing. These are great topics. I'm just going to try to provide a modest framework for how to think about empirical corporate finance. So this is really kind of about things I worry about. It's, again, starting point. It's not an ending point. And some of the illustrations I'll use are the things that I know about. I'll talk about those because I know them best. So my objectives over the next few minutes are three. I want to try to provide a clear statement of some things that I think pose difficulties for empirical corporate finance. I want to focus on an economic, sort of the economic aspects of this in terms of providing a parsimonious model that can identify the important determinants of organization form and also simultaneously performance. And there's a methodological element to this. I'd like to talk about some of the benefits of taking that approach. It gets us inside the black box. We're interested in the quantitative theory of the firm. We're interested in solving sort of econometric issues, and this kind of thing allows you to do quantitative policy analysis. So I'm going to provide, and this is I'm going to do this very, very quickly, and this is kind of for fun, just to sort of open a window into some of the ways that I think about empirical corporate. It's kind of just a framework that you can adopt pieces if you think it's useful. So I'll talk about a taxonomy, a very quick taxonomy, incomplete for our empirical corporate finance experiments therein. I'm going to complain. It's the usual complaint. I'll try to make it clear about endogeneity and the problems associated with econometric fixes for causation and endogeneity. I'm going to complain a little bit about this. These are things I worry about. I'm going to complain about economic content of our empirical designs, which I'm going to argue is maybe not as large as you'd like it to be. And I'm going to illustrate some of these issues in the model that Mike and I and Felix Meshke have been working on. And I'll suggest that this sort of modest framework provides opportunity for you guys in terms of research. I'm not saying what to work on, and just this is a way to sort of think about some of the things you might consider. Okay, so you guys all know what an event study is, right? Yeah, you've read thousands of them? Okay, so I'm not going to say anything about that. Another kind of corporate finance empirical experiment is to look at organization design and see, say, how board structure, board independence or board size or leadership structure on the board might affect decisions. So for example, are there more earnings restatements if you don't have independent boards? Is there more fraud? Are there more suits? That kind of thing. Or do managers act on behalf of the shareholders when it comes to a merger offer? Okay, so those are some examples of decisions. So the things I want to focus on are two other types of experiments, and these are both regression experiments. And one is performance on structure, where you regress some sort of performance measure such as Q, or pick your favorite, on some sort of characteristic of the organization, such as board independence or, say, pay performance sensitivity, which I'll call delta. Another sort of question is structure on structure. If you've got lots of options, for example, do you really need a very independent board? So you're trying to examine the connection between two aspects of the organization, in this example, pay performance sensitivity and board independence. So I think of that as structure on structure. So, and I'm not going to read this to you. This is just a list of choice variables that you might think of when you're thinking about structure. So I've got ownership structure or effective pay performance sensitivity in red because I'm going to talk about that. I'm interested in boards of directors, so I've got that in blue, but this should be broadly construed. This could be dividend policy, financial policy, this could be investment policy. Choice variables can be very broadly defined. Here's a list of possible performance measures. So if you're doing performance on structure, here are some of the candidates. I've got Q in red because I'm going to talk a little bit about Q. And oh yeah, maybe there's some stuff you ought to control for. There are lots of things that you would think that would drive two aspects of organization structure together, or might determine both performance and an organizational choice, such as board independence or pay performance sensitivity. Determine those things simultaneously. And here's a list, and in red I've got the nature of the production process, technology, and preferences, and those are some elements of some models that we've been working on. Okay, so I'm going to lay bare to all of you some of the worries I have. I think these performance on structure and structure on structure regressions, these nice linear things. You get some coefficients, they might have statistical significance, you might attach economic significance, but these are, the inferences and conclusions come from these reduced form empirical designs. So people, some are willing to attach importance to those results, others are not. And I suppose at the least all of this work has sensitized us to the importance of governance, organization, design. But then, of course, and this is something you've been hearing, since you showed up on campus, we worry about causation and endogeneity. Do we have spurious empirical results from these designs? And I claim responsibility for this too. For example, my paper with Jim Brickley and John Bishak in JE in '93, we regress. Remember the Jensen-Murphy sensitivity coefficients? We regress that on Q. We put Q on the right-hand side. Oh yeah, growth opportunities. You ought to have a bigger delta. And we control for a bunch of stuff. On the other hand, there are some other experiments that regress Q on delta, aren't there? So I'm going to say something about that in a minute, but certainly I'm not immune from the kind of complaining I'm doing. The other aspect of this is, okay, say you know, right, you suspect or know you've got some sort of issue like this, well, let's try the usual econometric fixes. And I worry that those are not effective. Now, we don't have a great laboratory necessarily to tell us when they are and when they aren't, but an assessment of how effective these things are would be interesting, and we're trying to work on some of those things. Okay, now the coffee is good at this time of day. This is not the coffee problem. I mean, I just want to use this as a very quick way to illustrate the endogeneity problem. So the main finding, and I love to make fun of medical doctors too, because they're not even real doctors, they're medical doctors. And and they're famous for not so good empirical designs in their research, but they're getting better. But this was an interesting finding. Years ago, they found, oh yeah, more cups of coffee means unfortunate birth outcomes. So the physicians and the public health recommendations, oh yeah, quit drinking so much coffee. Well, the problem was that people who are drinking coffee, a lot of times they're smoking, and hey, what the heck, maybe smoking might have something to do with both coffee drinking and birth outcomes. So here's a schematic of more coffee, more birth problems. And if you forget about length and number of work breaks for smoking, that relation with the dotted line may be spurious, might be biased. And then one thing you might do is actually control for that, in which case it might not be spurious, it might not be biased anymore. And even better than that, you might build a structural model of cellular biology and physiology to try to understand the way to best control for this kind of stuff, and maybe even figure out the determinants of length and number of smoking and coffee breaks too. Okay, so this coffee problem is absolutely representative. You remember my work, right? Delta on Q. Well, we have at least 100 published papers about Q on delta, and there are another 50 papers that are working papers that do Q on delta. And at any rate, here is, and I always laugh at this picture, this is a representation of what we've got. This is just different samples, different definition of who's the manager. Is it the team or is it the top 5 executives? Is it the top executives? So I'm not sure even that we've got definitive results on this, but this is just for my own amusement mostly, I guess. One more. So at any rate, I think what's definitive is what's in our data, and we regressed Q on effective managerial ownership and that thing squared and a bunch of controls, and we get this nice hump shape. So we think there's a hump like McConnell and Surveys thought there was a hump. And so then the next thing is sort of the interpretation. Now, one possibility is that, you know, when you're down here, delta's too low, and you need more incentive alignment, so maybe you ought to make delta bigger. The other possibility is, well, delta is too big, right, down on the other side of the hump. So managers are entrenched, and, well, that means I guess you ought to be at the top. Well, if everybody's at the top, then why would you observe the data that would allow you to estimate the hump in the first place, right? So some sort of story is required, and there are at least two kinds of stories. One is transactions costs. Oh, well, you know, it's expensive to adjust organization design. In this case, pay performance sensitivity. I mean, you got to mess with the compensation scheme. You got to undo some options, give them some more options, mess with stock, et cetera, et cetera. And so that's one possibility. So in that case, right, when you're really far away from the optimum and there's a lot of value, right, a lot of vertical value to obtain, that's when you adjust. So you wouldn't observe the data outside those red vertical bars, but inside, you would actually observe the objective function because the benefits of changing the organization are not large enough to offset the cost. So you could actually observe data this way. The other possibility is those data, the hump, approximately represents an envelope of optimizing organization form. So everybody's optimizing. These firms are, but they're optimizing at different places, right? Where their location, their objective function in this space depends on the nature of the product market, production technology, what industry you're in, and a whole bunch of other stuff, firm size. And so that's sort of the equilibrium optimization sort of story that you can tell. Okay, so sort of summing this up, when I'm worrying about things, well, you know, what are the economic forces that drive the connection between Q and effective managerial ownership? You might have a transaction cost explanation, right? In which case, and this is advice, be specific.
Yeah, I gotta take care of you. 5
minutes, okay. So it could be transaction cost explanation. So I suggest be specific if you want to tell that kind of story. Actually think, you know, and collect data and facts that have something to do with transaction costs. The other possibility is this optimizing envelope, and that's trickier because you got to build a model. It doesn't have to be a mathematical model, but some sort of thoughtful model that tells you why you have that. Actually, I was thinking about this this morning. Mike and I, our model's kind of mathematical, but Lalitha and I, Daniel, have a paper where we actually were well hedged in JFE in 08. We told both kinds of stories, just in case. Right? Okay. So at any rate, what are Mike and I doing? And I'm showing you this just because this is a representation also of the way that we worry about it. We specify an estimated structural model. And how we do it, we augment a principal agent model with the Cobb-Douglas production function. The important parameters here are the ones that govern the productivity of physical assets and the productivity of managerial input. And so those are Y and Z. And those things in the model with some other parameters drive the optimal choice in our model of firm size, what's inside the firm and what's outside the firm, and what the contract looks like for the manager, so the pay performance and sensitivity. So Z and Y are supposed to give rise to I and delta, and actually we also define Q in a natural way. We think it was a natural way in the model. Now the problem is, we don't know what Z and Y are, but we think we kind of observe firm size. You know, we go to CompuStat, we go to executive comp, we figure we can sort of guess at delta and I. So what we do, and there are lots of ways you can estimate these models. One thing you could do is assume Z and Y are the same for all firms in an industry, and use some sort of standard estimation procedure based on data on firm size I and pay performance sensitivity. You could do calibration. You could sort of assume a probability distribution for the Z's and Y's and run it through the model and see if the implied probability distribution in the I's and deltas matches what you see in the data. All right. We do something a little weird and unfamiliar. We take I and delta and figure out the Z and Y for each and every firm that would give rise to that delta and I as the optimal choices in the model. So that way we solve the model or invert the model to extract the Y's and Z's. And we do this because we think cross-sectional variation, not just across industry, but across firms within the same industry is important, and so that's why we chose this empirical strategy. Okay, so basic unfamiliar tests of this kind of model. Can you invert the model for every I in delta? Does the model sort of have enough span or flexibility to accommodate what you see in the data? And the answer in this case is yes. Do the Z's and Y's vary across industries in a way that makes sense? Well, the Z's, right, the Z's are managerial input, the productivity there, and it's high in business services and software and film, and it's low in some industries where you'd expect. Y, productivity of physical assets. Well, it's big in railroads, it's big in utilities, it's big in the places where you'd expect. Okay, the simulated Q from the model behaves a lot like the actual Q, say, that you would pull from the CompuStat tapes. And that was kind of surprising to us. This is really simple, one-period model. Obviously, Q in the real world has something to do with the future and present discounted value cash flows and all that stuff. But Q, our Q star, is correlated with things just completely independent of our modeling and empirical exercise. R&D, sales, total assets, advertising, leverage, and we were surprised by that. So does the model explain the hump? Yes. So our simulated Q, if you took our Q and regress it on delta and delta squared, you get the hump. And it's got a maximum about where the hump in the data appears. It's got a lovely shape. So the model actually delivers that, and I mentioned that Q star, our model Q, explains actual Q. So then we address Y. So say we didn't really know the functional forms by which Z and Y affected performance and organization choice. So let's put simple forms of those on the right-hand side and regress Q on delta and delta squared. Okay. Well, it turns out that those Z's and Y's, right, those productivity parameters, drive out the hump in delta and delta squared. So those things actually are driving both delta simultaneously with Q. Okay, so that's evidence that the Z, what we've captured here is something that explains sort of an economic determinants of pay performance sensitivity and performance at the same time. All right, so we worry a lot about empirical fixes, econometric fixes, and so what we do is we have this model, and we forget we have the model, and see if standard instruments and controls on the right-hand side drive out the explanatory power of delta and delta squared. Do those things get rid of the hump? And the answer is no. So we didn't do very well with two-stage least squares. It was unstable, and coefficients were flipping around. Fixed effects work, but we worry about throwing the baby out with the bathwater. So we continue to worry about econometric and statistical fixes, and I think part of that worry for us is showing up in concerns about linear specifications as opposed to nonlinear specifications that might come out of a sensible model. Okay. Last thing this kind of model might allow you to do is to do policy analysis in a quantitative way. So, for example, say a special paymaster has an opinion on what's happening with pay performance sensitivity, and there is a regulation that's adopted that restricts pay performance sensitivity to be below some number. Well, what you could do is take Y's and Z's estimated from previously in the data when there was not a constraint, and then use that and then impose the constraint on all of the different firms, and some firms will be constrained and others will not, right? And for the firms that are constrained, now figure out what the optimal firm size is going to be, given that they're constrained, and what the resulting performance measure Q is going to be when they're newly constrained, and therefore understand the implications for other choices in organization form and for performance. So this is a way to approach quantitative policy analysis with this kind of model. You could do this with board independence and all the listing requirements with that, so there are lots of things you could do this on. So at any rate, here's the summary of all my fears and worries. I worry about endogenous causation. I worry about econometric fixes that sometimes don't work. But the big thing is I just worry that our regressing A and B and then B on A and our naive linear, I mean they're not always naive, but linear specifications, we're not developing empirical designs that really help us isolate the economic forces that determine jointly various characteristics of the organization, and also performance. Pick your favorite performance measure. So that's the big worry. And you know, we've got an example. I don't know about if this is the greatest model of all. And by the way, Bill gave some good advice for people trying to publish papers. You know, get to it, be responsive to your referees. You know, Mike and I we've had drafts of this paper for some time, and at least one journal editor in the room has been extremely patient with us on this, and we've had great referees. I got to say. So we're trying to. My excuse is we're trying to be unbelievably responsive to the referees, is what I would say. But we're still working on it, and we're trying to isolate the economic forces associated with product markets and production processes that drive these things together. Nonlinearity is floating around in here. This is a response to calls for quantitative theory of the firm by Zagalis and others, including Charles Himmelberg, and you can do policy analysis. And by the way, this is just an illustration. A bunch of other people are starting to work on this kind of stuff. Chris Hennessy and Tony Whited are doing very interesting work. I think Alex Edmonds, Carlson Fisher, Jean Marino, Gavix, and Landier. Terrific stuff. Read everything you can by them if you're interested in this kind of approach. Thank you, Mike.